Welcome to the PEAKS 12 label-free quantification video tutorial. In this video, I will explain the steps of the LFQ algorithm in PEAKS 12, how to set up the workflow, and how to view the results. In PEAKS 12, users can choose between an identification-based or feature-based algorithm for LFQ. Let's look at the identification-driven algorithm first. The first step is feature detection. A peptide feature is the bell-shaped peak encompassing the retention time range over which the peptide elutes, the m/z range of the isotopic profile, and the peak intensities. The sensitive and accurate algorithm in peaks can distinguish between overlapping features. In the identification-based algorithm, the features are then associated with the corresponding peptides identified at the MS2 level. Retention time alignment is then performed and features are matched between the samples. The quantifiability of a feature is scored based on similarity in m/z, retention time, EXI-C shape, and isotope distribution across the different samples, as well as signal-to-noise ratios, frequencies, and feature intensities. This is reported as a quality score. For DDA acquisitions, peptides are quantified based on MS1 feature abundances. The peptide feature area is determined by drawing a curve over the peptide elution and calculating the area under the curve. The sum of the areas for each isotope make the peptide feature area. By default, for DDA, the three most quantifiable unique peptides are used for the protein ratio estimation. Finally, the protein change significance is calculated using the ANOVA test and reported as significance in the result. The significance is the -10 log of the p-value that came from the ANOVA test. The feature-based algorithm proceeds in a similar way as the identification-based algorithm, except the feature identification association is performed after all of the other steps. This allows for quantification of all features, regardless of whether or not they have an associated identification. Now that we understand the LFQ algorithm in PEAKS a little better, let's take a look at the workflow setup in PEAKS. To perform a label-free quantification analysis in PEAKS, select the PEAKS Q workflow. Select your data refine options and set your database search parameters. Next is the quantification step. At the top of the page, select Label Free if you would like to do a label-free quantification. The next step is to organize your sample groups. Highlight the samples that you would like to be in a group together and press this button to create a new group. You can change the group names or the group colors. Under Match Between Run, you have the option to select or unselect ID-directed feature alignment. If you leave this checked, the ID-based algorithm will be used. If you uncheck it, the feature-based algorithm will be used. You can also set the mass error tolerance and the retention time shift tolerance for the match between runs. You can select Auto Detect for the retention time shift tolerance. You can also set the minimum feature intensity required for a feature to be included in match between runs. Select the retention time range that you would like to include in the quantification. You can also select your base sample. You can either choose one of the samples or pick an average. There are various peptide feature filters. You can filter the peptides that are included in the quantification by average area, quality, the peptide ID count per group, and the charge. You can also select how many confidence samples are required per group in order to be included in the quantification. If you are expecting proteins to be in some samples but not others, and you still want to include those proteins in the quantification, you should leave this at 0. Select Use in Group Coefficient of Variation filter if you would like for at least one group to have a coefficient of variation less than the threshold to be included in the result. Now let's look at the protein filters. You can choose between setting a minimum significance value for the protein to be included, or you can choose an FDR. This setting can be easily changed in the Summary tab as well, so it's perfectly all right to leave this at 0 for now. You can also filter by fold change, so only proteins that display a certain fold change between the set values will be included in the result. You can also select the minimum number of peptides required for a protein to be included in the result. Check Modified Form Exclusion to exclude modified peptides in the event that there is both a modified and unmodified form. You can also choose to remove outliers. As well, you can set how many top peptides you want to use for the protein ratio calculation. By default, the top 3 peptides will be used, but you can use a minimum of 1 and a maximum of 20. Finally, you can choose your normalization method. Selecting no normalization will mean that no normalization is performed. Use TIC will calculate the normalization factors using the total ion current. This option should only be used when you're expecting a consistent level of protein expression across all the samples. Manual input can also be selected. This will use the same algorithm as in Use TIC. However, you can set expected ratios between different samples. Finally, you can use internal standard proteins if you've modified this analysis from a previous database search. This allows you to choose particular proteins that you want to use to normalize your samples. If you are unsure of which normalization method to use, we usually recommend starting with no normalization. If you choose to run the quality control step, you'll notice that you have a few more attributes to choose from now that you've run a label-free quantification. The last step is to choose your report filter parameters. Click on Finish to start the analysis. Now let's take a look at an LFQ result. You can see over here in your results that you have a new tab to click labeled LFQ. Clicking on it will take you to the summary page of the LFQ result. At the top of the page, you can change the significance value, the FDR, the fold change, and the minimum number of used peptides. Click Apply to make the changes, and the changes will reflect in the figures on this page as well as in the Proteins tab. You also have some additional figures that you can click on up here. You can have sample correlation at the protein, peptide, and feature level, the group correlation at the protein, peptide, and feature level, a density ratio plot, and an interactive heat map. Hover over and click on a protein or protein cluster to bring up a variation trend chart. This chart can be exported. On your summary page, you'll find a protein profile heat map, a volcano plot for proteins, a retention time shift distribution and M/Z shift distribution with respect to the base sample, a percentage of missing values in each sample with or without the ID transfer or match between runs, a PCA plot by group and sample, protein covariance values, result filtration parameters, statistics of result, and a summary of your search parameters. You click on the Proteins tab, you'll notice that it's laid out in a very similar way to the Database Search Result Proteins tab. Now you can see a significance value in the chart. As well, you get individual heat maps per protein. There's one at the sample level and at the group level. Hovering over these heat maps will display the area and the ratio. You also get a volcano plot to the right here. If you filter down the proteins that are in this chart using the protein view filter, these changes will be reflected in your volcano plot as well. As well, if you have more than 2 groups, you can change which groups are used in the volcano plot using these buttons here. Click on Update Plot to make the change. Clicking on this Peptides tab beside Coverage will show you which peptides were used in the calculation. You can see that because we chose to use top 3 peptides, in proteins where there is more than 3 peptides, only the top 3 highest quality peptides are used in the protein ratio calculation. On the Peptides tab, we also see a quality score, the significance score, and the sample and group heat maps for each individual peptide. Once again, hovering over the heat map will give you the area and the ratio. Down here under Feature Details, you can actually visualize the feature of each sample. By default, 1 sample per group will be displayed. Clicking on Sample Features displays a side-by-side plot of retention time versus M/Z for the displayed samples. As well, you can look at the retention time alignment. The Features tab looks very similar to the Peptides tab. One unique feature about this tab is if you go to the Feature View filter, you can check or uncheck with identification. If you chose to do a feature-based analysis, unchecking with identification will show you all of the features that were quantified, even without an identification. Clicking on the Export tab, you can see all of the results that are available for export for the label-free quantification. Select the results you want to export, choose which folder you'd like to save it into, and click Export. We hope you enjoyed this tutorial on label-free quantification in PEAKS 12. For more information, you can visit our website at bioinfor.com. Thank you for listening.